In the last video, we were talking about data and information. So the main difference is data is basically raw facts and figures standing alone with no meaning to them individually. But information is the, the data that has been processed to get some meaning out of it, right? Now, data is not useful alone, but information, it is useful for making decisions, right? Now, types of data, every company stores different kinds of data. We have structured data, which is highly organized, which is stored in rows and columns in a table. For example, this. Now, it can be stored in MySQL, PostgreSQL, Oracle, or SQL Server, and it is easy to query. Now, SQL may we have basic syntax as select star from employees that will show all the employees data in the employees table. This is the table name. Now we have semi-structured data. It has some structure and it is not perfectly tabular. For example, in JSON format or in XML format, right? And then we have unstructured data, which has no predefined format. For example, images, videos, audio, PDFs, emails, CCTV footage, or social media posts. Now, Spark is designed to work with all three types: structured data, semi structured data, and also unstructured data. Now, what is a database? A database stores organized information. For example, imagine a school, instead of writing student records in notebooks, they store the roll number, the name, the marks, and other information inside the software. For example, you have the ERP softwares. So that software is called a database. Now, popular databases are Oracle SQL Server, PostgreSQL, MySQL, which we discussed above. Now, why databases were invented? So, imagine Amazon stores customer data inside Excel. We have customer.xlx, XLSX is the extension name. Now, suppose Amazon has 100 million customers, and opening Excel basically leads to a crash. Then we have searching, very slow, two employees editing, conflicts, security, none. Hence, databases are required. So benefits are fast search, security, backup, concurrent users, and transactions. SQL stands for structured query language used to communicate with databases. For example, show all employees becomes in SQL, select star from employees. Find salary greater than 50,000 becomes select star from employees where salary greater than 50,000. Now, what is data engineering? This is where things get interesting. Imagine Netflix, millions of people watch movies, pause, search, like, dislike, comment, rate, subscribe every second. Every action generates data. Now, this is an example here. User number 123 watched Stranger Things at time 8:15 p.m. Device was mobile. Now imagine 300 million users. That is billions of records. So the question is, how does Netflix store all of this, and how do they clean it? How do they analyze their ratings? How do they recommend the movies to people? The answer is data engineering. So it is the process of collecting, storing, cleaning, transforming, moving, and preparing data so others can use it. Think of it like a water supply system. Water flows from a river to a treatment plant and it goes through pipelines. And from those pipelines, we are given water uh, to our homes. Similarly, raw data goes to the process of cleaning and transformation, and then it is fed into a database, to a dashboard, to a machine learning pipeline, and that is where data engineers build these pipelines. Who uses the data? A common interview question is, who are the stakeholders in data ecosystem? So we have customers, they use the applications, and applications are built by data engineers. Data engineers clean the data and they store it in data warehouse for business intelligence or ML purposes, which are managed by managers who make these decisions. So data engineer builds pipelines, data analyst creates reports, data scientists builds uh, build ML models, and business users make business decisions. What does a data engineer actually do? Daily tasks like reading CSV files, reading databases, reading APIs, reading Kafka streams, cleaning data, remove duplicates, filling missing values, convert formats, join tables, load data, schedule pipelines, monitor failures, etc. And finally, we'll be getting to the most important part, that is ETL. It stands for extract, transform, and load. Where extract is taking data from source, for example, CSV database, API, JSON, then transform, cleaning the data, and then